Hi, my name is Preston Jiang. I'm excited to present our work on learning hierarchical temporal representations via dynamic predictive coding. Different cognitive tasks require predicting future events at multiple timescales. How does the brain learn hierarchical temporal representations and use them for future predictions? We propose that the brain learns a spatial temporal generator model with a temporal hierarchy. In our formulation, higher level states modulate the transition dynamics of lower level states by generating a mixture weight vector that linearly combines a dictionary of transition matrices. At each time step, spatial temporal prediction errors correct the lower and higher level estimates of the latent states. We implemented this model in a two-layer neural network. After training on natural image sequences, the first level neurons develop both separable and inseparable space-time receptive fields similar to those of simple cells in the primary visual cortex. The second level response autocorrelation is higher than that of the first level. We demonstrate the temporal hierarchy of the model in more detail using the moving MNIST dataset. During inference on this example sequence, the first level activities displayed fast changes, while the second level activities spanned longer timescales and only showed notable changes when the input dynamics changed, eliciting large prediction errors. The second level responses clearly formed clusters by input motion, but not digit identity, showing the learned hierarchical temporal representations are disentangled from the spatial input content.